Or so something important. What am I doing? Last time we said something about duality, especially we said something to be what term of be for any two feasible primal and we have, right? We can understand. Anybody remember? Obviously, trying to say that the dual solution, the lower bound on the private product incomes. So that's being duality. What I want to prove today is that there is in fact equality whenever there exists both primal feasible and dual solution. Yes, primal feasible as well as dual solution. We want to show that this is actually equality. That at the ordering, there is that equality. Some background is needed before we go there. Background is for us. So you will see one more application of what you have learned so far. And the separation there. Okay. So here it is. Or that ATM ratings. Yes, this is given to you. Then that one of the following two statements. Okay. There exists an X. Here, or it's Y. Here is Y. Try to absorb what is going on. So you're given a matrix A and a vector B to begin with. What are you asking for? Statement A says there exists an X such that A is equal to B and X is greater than equal to 0. The theorem says either this happens or there exists a Y such that A transpose Y is greater than equal to 0 and Y transpose B is less than 0. So does it appear plausible? What about why can't they happen simultaneously? That's also being excluded. That's not difficult. That both simultaneously cannot.
If you multiply the first equation by the Y transpose.
Okay, so you should begin with, let's suppose both X and Y following the properties hold. Then what are you going to do?
So with the first equation X equals to B.
Yeah.
by multiplying the y that we get in the second condition
Okay, okay, like why?
by y transpose post multiply, pre-multiply, then it will be A transpose y whole transpose into y equals to y transpose b. The left hand side is negative, while the right hand side is positive. Okay. Because A transpose y is positive, and you are multiplying with x, and x is also positive, so the multiplication will be equal to 0, while the left hand side, right hand side will be negative. So there is a contradiction in equality.
Let me follow what is it. So you can do it on your own. I will do it anyway. We just wanted to see that these are complementary conditions.
Yes. So we can multiply y transpose on both sides of first equation.
Okay.
Then the right hand side is negative because we already have it. And so we know that if A is positive, then A transpose will also be positive. By the way, we have
What do you mean? A is a matrix.
like every term is positive by that.
Where is it written?
So like x is greater than equals to 0, that simply means that every element of
X
X.
is. But what about A? You're saying A is greater than 0. What does it mean?
every element of that.
We haven't written anything of that. Let's suppose both exist. Both-
In that left hand side, if we take the transpose once again.
Tell me, you multiplied y transpose.
Yes.
So y transpose A is equal to y transpose B, which is less than 0. That much I know. Now what should I do?
So in the left hand side, if we take transpose once again and save, then that will be essentially A transpose Y and X transpose is also multiplied. So since X is positive, X transpose will also be positive, but A transpose Y will be positive, but right hand side is negative and left hand side.
Everybody okay? I want you to do it, but just say it. So there is nothing more to be done. What we need to do? We multiply. Let's take by yes. What is it? X is equal to B, so it is y transpose B. And by our hypothesis, this is 11 B. Now we're going to manipulate this. What is this product also equal to the whole transpose of this? So this is equal to X transpose A transpose Y. Now A transpose Y is greater than 0. X is greater than equal to 0. So this quantity is equal to one when is telling is less than 0, other when is telling greater than 0. So both are negative. So that takes care of that both can this. Now you want to show that if one, the other doesn't exist. So now, is there anybody who understand what is going on? Is there a physical feeling for it? You can think of a geometry. What is telling you this condition? In geometry.
The equation has a solution.
Yeah, can you see geometrically what is that?
We rise in the column.
Yeah. So if this happens, why can't this happen? Right? Not asking for proof. Is there any way to utilize?
First happens,
Yeah.
so the rank of A
Yeah.
will be exactly, at least if one solution exists. Okay. So if exactly one solution exists, then we can say the rank of A is exactly N.
And why one solution is so important? It's saying that exists next. They can exist more than one.
Yes, so in that way we can say that the m is greater than n.
Let's see if something takes from the code. So what do we want to do? It doesn't hold. Keep me honest here. It doesn't hold and moves. That's not. Then I want to show the people.
Just one thing. If we have a equation like Ax is equals to b, it gives me a convex body, like a convex set, right? Right now we have A transpose y greater than equal to 0.
Yes.
It's also a convex set, right? And we can give y transpose b as a line, like as a half space. And what this condition is saying that those two are disjoint.
Which is
And the convex set defining satisfying A transpose y and the half space that y transpose b,
okay.
those two are disjoint. So
So this sits in somewhere else, Ax equal to b. So what you want to show is that if this exists, that can't.
yes.
Okay. You close it. So can you bring b into the picture?
Okay. So now Ax equals to b is exactly the boundary of a convex body.
Okay, what is that convex body? Ax greater than equal to b. Yes, you want to define that. And you're saying such an x where equality is met, it's at the. Well, okay, so
So if the second condition says if second condition is hold, that means that the convex body defining A transpose y equal to 0 and the hyperplane hyperspace below it is like a tangent to it, and you cannot inscribe a convex body of x equals to b in between those two vectors.
more or less there, but we just have to say right. Okay, so let A. This comes writing the columns. And let's define Q to be the cone. Essentially, span column vectors equal to S is sum. So now lambdas are not necessarily being. That's good. Here is the definition of definition of twist game. Capturing all vectors which are positive linear combinations or non-negative linear combinations of its vector space. It's not a complete span. It's just a non-negative. Okay, so A doesn't hold. What can you say about B? So A does not hold means what? Keep writing in your notes so that I don't have to go back. That Ax equal to B. There is no X such that Ax is equal to B and X greater than equal to B. What does it mean in terms of Q?
It is not.
If B a member of Q, B is not a member of Q.
Not a
I think best to write in a notebook only because otherwise I will keep going back and forth. The condition A and the condition B. At least keep it. Now if it doesn't hold, it means what? that there is no such x, for which ax is equal to b and x is equal to b. That means that it will be not the number. Because if it did otherwise, it would have created an x for which x is equal to b. What is this? It's nothing but a you know multiplying an x, which is adding the columns. And b doesn't belong. Okay, what kind of strategy? One minute, second. What more can you say? Among non-empty closed x. All of them. Why is it non-empty? Zero belongs. Okay. Why is it closed? Sorry. Slightly more tricky to. It's not one line. Why is it convex? This is easy to check. You check this. Now, given that Q will have all these properties and B does not belong to Q, what is the biggest hammer we have created for us? So Q is somewhere. Q is somewhere. B is a point. Does not belong to Q. And Q is has all the properties we needed. So there exists a hyperplane. So let's call that hyperplane. Notes. Then we build alpha common and that comes. Okay. I want to edit. What do I want to show? I want to show that condition B is satisfied. What do you think is going to happen? Now we have anything essential. I want to create, keep looking for everyone. I want to create a y. There exists a y, so I'll just give you a y for which the condition will work. What y will work in this? Sorry? Right. Alpha. Okay, any such is fine as long as it works. So why is what? Alpha. Yeah, it is. I mean, if it's in the hyperplane, then right transpose. Because in right transpose, B will be less than. Okay, so suppose the point of the hyperplane, what property does it have? So I can't transpose. The parameters are I can't just I can't transpose x minus beta is equal to 0 so hyperplane. Okay. So we want so like alpha, so we want y such that okay, I'm going to.
We can take the projection on the hyperplane by beta.
Whose projection?
From B, we can take a projection that also cutting the hyperplane and
Projection to what?
condition to hyperplane.
So what is the cut?
Means it will give me a point in the hyperplane y and use that y.
And that will satisfy all the properties. What? Give me at least an argument, right? Why should it?
Yeah, so the separating hyperplane says that the point is in one side of the hyperplane and the convex body is other side of the hyperplane.
Yes.
So
Can you use that fact somehow? Just projects are not enough.
yeah, so that point that we got from the projection is lies on the hyperplane. So if we take B transpose y, it will be to say that it is one side, we can make it as less than 0. And
Alpha is to be record something.
yeah, so from the equation of the hyperplane, we can get the alpha beta. After putting the value of B, we get the projection, that is y.
Why don't you tell me what the y is? I want to create a y, right? So just tell me what the y is. What do you say about beta first of all? Is it positive or not? You said something about 0 belonging to Q. Does it imply something about the value of beta?
So in beta also should include 0 because alpha transpose 0 is just 0.
One is on one side, one is on the other side. And I can do the strict separation. You can always create the beta, so that beta is greater than 0. That's very important. That's also included. Why do I need beta to be greater than 0? Only when I want to divide something. So, I was completely what do we know? There is alpha. So that
Suppose B greater than beta and
S is greater than beta. S. Now given that we don't know this is very important so that I can divide something by it. So what is your guess for what?
Alpha transpose by 1 by beta into alpha transpose.
Y is
Beta inverse alpha transpose.
what quantity will it have?
So, minus, oh, you have to have a minus.
Minus what? So why should it not?
It's to all in.
No, minus two. Why is this vector the right hand?
So we have that beta is a scalar and beta is positive, non-negative. So we can divide by beta.
Other two.
Yeah. So that will give me that y. If we look at y transpose b, will be transpose. Okay. That will not be alpha transpose. Then it will be. So y transpose b will be if we take that minus 1 beta inverse alpha, not the transpose, then y transpose b exactly.
See, you're essentially trying to only get one condition. I need two conditions. Go back to your notes. Condition P requires two conditions.
Yeah, the second one also. Wait,
How are you ensuring the second?
that will greater than like alpha transpose 1 by b alpha transpose is greater than 1 for all s.
What for these conditions?
Yes,
You're attempting this one.
yes.
What about this?
So I'm just saying that we will get not a transpose, we will get s transpose y greater than 0 for all s belongs to that convex set.
Yes.
And that s I can write as the in terms of the alpha vi that you have chosen for convex.
Yeah, so then y has to be some function of vi or some coefficient of whatever we wrote.
Yes.
Okay, so you're not saying that.
Okay.
It can't be simply we have to
Yeah.
create whatever S you're creating. What was
Okay.
S?
So just
S was written as some lambda I vi.
vi.
Okay, so now it can't be simply this.
Yes.
That will become function of lambda I.
Yes.
If you don't get it, why this is to work in your own way. So far, what have we done? We have created this hyperplane, we separate so that this is true as well as this is true for all S. And what type of S is this? What is the classification of an S? This is comes element of this. So for every such thing, this is less than beta. What does it tell you? What do I do to pick my Y? I want the two conditions to be satisfied simultaneously. The second looks like it's more or less there. What is the first condition I want? A transpose Y to be greater than 0.
Yeah, I did a mistake.
It's okay.
No, the point is,
No, I-
So the way I define y is a scalar, y is not a scalar, it is a vector in.
Yes.
So that will come from the PIs.
You got it. This is working for the rest of the card. Okay. So now what do I do? I already have this. And S is of this type. All I want to do is, so this is not correct. Some adjustment has to be done. Want to create a Y such that both those conditions are simultaneous sets. So think about what is it. Everything is on board. All you have to do is just to pick up the right way and use the two properties. That's it. Because for a fixed lambda, let's say for any lambda greater than 0. Where does this belong? Belongs to Q. In particular. So given that this belongs to Q, this inequality is satisfied for all Q. This is just one element of Q. Okay, so what will give me? Lambda by is alpha. And then we now what can I really do here? And remember, lambda is greater than 0. I can easily divide if I want it. Then divide or should do what? Then alpha transpose bi is less than beta by lambda. It's like this one is. And for all lambda greater. And beta remember is greater than 0. So what does it mean? This is true for all lambda greater than 0. This quantity is greater than 0. So if I take the limit lambda going to infinity, what will this look like? It will become less than 1%. So as lambda goes to infinity, alpha transpose bi is less than equal to 0. So what does it mean? Suppose this is true. We're almost done. What should be my choice of y? That's all. This is for every item, but I'm not taking anything special for any one particular year. This is true for every single column of A. So if I have to pick y is equal to minus alpha transpose or minus alpha, isn't it true that A transpose y is actually greater than or equal to 0? What is A? A consists of only the columns of V1, V2. For every Vi, I created a vector alpha for which the inner product is less than equal. That essentially means that alpha transpose A is less than term and. So my choice is y is equal to minus alpha. What does it satisfy? Does it satisfy my two properties? What are the two properties I'm looking for?
You transpose y.
You get lower,
A transpose Y is greater
A transpose Y
than equal to C.
and
And Y transpose C is less than equal to C.
that's the students. Is it satisfied? By my choice. It's true for every single column vector of A. It better be true for the whole matrix itself. Now let's switch the sign. Minus alpha. So it's suitable. What will Y transpose be? Okay. Just switch the signs. But with B is greater than 0, you just switch the signs. This is a very important result, even though proof is not very complicated. Something is getting applied. And all we needed was the one strong. Fixed average is always between a point and close convex on these. Is it clear now at least what went on? You know summarize?
What is the connection between A and that one?
The these are nothing but the
Okay.
vectors, column vectors are areas. What are we working with? We're looking at all possible combinations. Think of it as positive span. That's what your QV field is. All vectors you can create by taking non-negative coefficients. That's your Q. And B, by the very definition, falls outside. That gives you the starting point that there is a hyperplane where all vectors to the left and all vectors to the right are separated in the very square. Alpha transpose is greater than alpha transpose. It already is clean everything. This is directly, so even if you have chosen y to be minus alpha, as long as you have shown beta to be greater than 0, beta. This requires a one more argument that you can take for every lambda. This is true, so you can take lambda over infinity. You understand? So go back home and visualize what really happened. It's very important to observe this. Very useful. So there is a equivalent which separately is called Farkas lemma. Use both by doing so. Let me say that time permitting, I'll come back to this to just give you the notes to prove the similarness. That again results. But at least note it down in the notes. We call it the two double, which will be taken two back. There exists y. Equal into then there is y. Very similar type looking things and Farkas lemma used to prove this. We need both of them to prove this strong logic. So now what is saying compared to before? There either exists an X, such that X is greater than B, or there exists a Y, so that A transpose Y is equal to 0, Y transpose B is less than 0, Y is greater than 0. These are equivalent statements. This one you can see directly. Here, this minus one is easy. This direction required. We keep calling these 1 prime, 2 prime, whatever. And you will. So, keep it. Oh, so now let's go back to. This convenience here, you trying to find a problem in the max problem and do it as a new problem. So now what it is, main point. X. From being duality, which direction do I know? The solution to this, the optimal value is at least half of that. So, it's already feasible. That's the most important. So here, let's call this ground duality. There are exactly 4 possible. Then go to previous slide.
In the first condition, if we get so y transpose is greater than 0 means will become minus r where r positive. So we can divide that scalar and bring it to including the y transpose. So that way we can get the minus one also. Right?
I'm not saying you can't get it.
That is the idea, right? Or is it not obvious?
I'm not saying obvious, it requires some. From here to here is for free. To here to here it will be somewhere. That work in mind and one is divided. There are actually 4 possibilities. What are they? 1, 4, and more feasible. That's not the existing case. The existing case is still there. Feasible. Infeasible. Infeasible. Does it mean rules are bounded? Where the minimum value is running off to minus infinity. That's what it means. If there is no prime feasible solution, then don't expect to solve that one. And similarly, the output also. Rule is infeasible. In this short form, technically I should write. If there is no solution which is feasible for the prime, this is the not as prime, but this is how it is used. Prime of is equal to primary feasible. Just get used to it. Dual is infeasible. Primary is. And the primary is fine. If both are feasible, then the oxygen value is the same. This really is strong. We're not true without any more caveats to current competence. We need some extra conditions. Just feasibility is not. For example, we had something called stated condition required. Strict feasibility. This is all is saying feasible. So it can be on the boundary itself. We are not asking for something more than that. When you go to look at a generic convex optimization problem, which will not suffice. Everybody say what they related to it. With everybody says that you can create a panel and do it. For which there are no physical solutions, both of them. If not, go back home and try it. Yes. Both should not physical solutions. And we try to do all these solutions. All right. So I built up the climate using Farkas lemma. Now, how do I use the Farkas lemma? Let's say this. What are you given? Primary is inferior.
You can use a second one.
You have to go specific.
Yeah, so basically,
Farkas lemma prime.
yeah, so there will be exist a y such that
Just tell me what which lemma? Lemma or lemma prime?
lemma. So that if there exists a y, means the primal is infeasible. So there exists.
What does that mean? That's the first thing you should say. Primary infeasible means there exists no x.
Yeah.
For which x is less than equal to b. That's what it means.
Yes. So we can get a y such that b transpose y is less than 0 and a transpose y is greater or equal to 0.
Okay. See, what you have to, so you should always think, what are you given? You're given that there exists no x for which x is less than equal to b. What do you want? You want to show that the dual is unbounded. So where should it go to? It should go to minus infinity. Somehow you have to create a solution.
That is as much as
Wherever I want. So essentially something like you have to make sure that a solution of the type minus lambda something is feasible, where lambda is greater than 0. And then I can scale lambda to wherever I want to take. So somehow you have to create a vector which has a lambda multiplier, lambda greater than 0, for which minus lambda something is feasible. See, that's what I need. When I say dual unbounded, it means a feasible solution for which the value is tended to minus. To think of the minutes, like easy answer. It's not that difficult. All the difficulty is captured by Farkas. The target is clear. What are given and what I want to go. Not very difficult. Look at the Farkas lemma 1 prime. What do they say? there is an x such that x is less than or equal to b. Here we are exactly in the opposite. So we know that 2 prime should hold. If 1 prime doesn't hold, that's what you are given. 2 prime should hold. Use 2 prime to construct a solution which is feasible for the dual. And whose value I can take it to minus infinity. That's all our goal is.
Now y you can choose lambda y.
What you can choose.
That for the lambda second for the second theorem, the second condition says that there will be y such that A transpose y is equal to 0 and y transpose b is less than 0, right?
And y is greater than equal. Everything is given.
Yeah, so you can just choose y tilde as lambda 1, where lambda is a positive number. That would work.
Slightly more.
We take C as 0.
No, that's not allowed. For generic C or do this. We are not making any assumptions about C. But it's not too far from what you said. It's just some adjustment is needed. So proving number 2. Not prime. Find that. One prime. Therefore, 2 primes. Exist. By bar such that it transpose by 1 is within the field and by 1. This much I'm given. What about construct of y? So they will satisfy these 2 constraints. What is the y? We should work.
Take some by which works and then add a multiple by 1.
Okay, this will be done. So what's the way?
By
Y is equal to
A transpose.
no,
Why not is a solution which works for AX equal to C? So, yeah, I mean,
say any C is equal to
any
then it take lambda times y. What property does this represent? So y is such that A transfer y is equal to C. Any feasible that's how my y is. Guarantee coming from 2 prime is that there exists a y bar such that B is good. What about y tilde? Is it feasible? Yes. What is A transpose y bar? A transpose y. Because lambda times A transpose y bar, which I know is 0. This gives me C. That's equal to C. So y bar is feasible. And y hat is greater than equal to 0. Because y is greater than 0 is greater than 0 for any function. You satisfy both these conditions. So it is doing this. So what is the value it's going to take? When lambda goes to infinity, what is the value it's going to take? And why?
Because it's y bar transpose b is negative.
Exactly. This is negative. So what is the optimal value for our? No, it's not a clear notation. So let's say v of y equal value of y. This is equal to how much? B. And what is y hat transpose B? Equal to A transpose Y. Simply Y B trans plus lambda. This is negative. This is what? Transfer constant. What is the one?
We are fixing right.
For fixed part, something like this. And lambda allowed a free digit. The lambda was to infinity. Let's see. So, really one punchline. Primal infeasible essentially means one kind of, and the one not holding one kind implies two kinds. So this comes out for free. Once you have the Farkas lemma, these things are just. Do something very similar. The whole is later, which is really what you want. But in telling you something, suppose you're given certain problems, how will you use such problem? You're given the LP problem, and you know this result is the primary feasibility implies dual elements. Is it useful at all? Such a property. What kind of statement is this? Primary feasible implies unbounded dual. What is our objective? We want to actually solve the problems. So if you look at a problem, look at it in dual. One is primary, one is dual. How do you think one can do such a result? The primary feasibility implies dual unboundedness. So suppose you want to solve a dual problem. You wrote this primary, and before there is no feasible answer. You don't have to go back and actually solve it. You just directly claim that this is a hopeless dual, which is going to run. So feasibility typically, at least in an LP, it's not easier to check. Depends. And the quotes, not necessarily to the C. It also depends on how you write the problem. See, what is essentially going on between primary and dual? The number of constraints are getting exchanged. Have you noticed that? Sometimes the problem, the number of constraints you want to write are too many. If you go to the dual, yes, the number of constraints reduce. That's why there is a greater advantage for reduced time. Oh, so let's try it. So these results are good, but always have something handy with me. How no ever was used. What is in dual? In terms of our Farkas lemmas. The rule increasable means what? There is no y. Such that A transpose y equal to C and y is greater than 0. Which Farkas lemma should I apply? The assertion is telling me that there exists no such y. What is the alternative which is good? There are two theorems to look at. One. Not so To do it simple, this implies that. Look at lemma, just the lemma. The lemma of one. So, B words. The statement B.
Where exists y. So that A transpose y is greater than equals to 0 and y transpose b is.
Yeah, so let me write, so B words become that. Getting this next that. B next that. It's now do the similar exercise we just did. Now we are given this, all I wanted to show is that primary is unbounded. Primary is the max problem, so now we go plus infinity. Okay. X bar. Yeah. Let me that X hat is feasible and what is talking about. This need to take two ones, whether X hat is feasible, say A bar is, so X bar is feasible. Different primary objective value at X1. Is this true? Is it feasible? Yes. Wait. What is feasible? What about this? It should be true. Because it is now. Or C transpose it's tilde is less than then transpose X. Transpose that there will be below another minus this plus this plus. You are like say three copy of each other. But you still need those lemma and lemma prime. Here we use lemma, earlier we use lemma. But if you remember one, the other is, you should also remember the other one is okay. Any one's infeasibility tells you, others are not.
It's not an implication.
Not an implication, just to remember. Anyone's infeasible?
But it's not a, it's one of the four conditions. Yeah.
You say, dual is infeasible implies.
Primary
Primary
would also be invisible.
infeasible.
So it's not an implication.
It's not, so yeah, we take two. Moving this out. This is what comes. It's possible that both are not. Right, both are infeasible. So we are strictly using the fact that there exists a y. So if it's there is no such y, you would not get this new vector y. It's intrinsic, this proof this is y exists. Oh, now that's right. It's from the right. Is anybody in the proof? Okay. Now we are saying both are feasible. Both. Right. And the other hand, you already have big duality. That will be important. You want to claim that there is from duality. We already shown Lemma is greater than equal to duality. What you think of the main problem is that much as the dual problem. The max problem. You solve the time and do it. So once you go home, you should also slightly look at what we did last time. The road primal is the main problem. But I'm making sure that everyone understands this. It doesn't really matter which one write this time. Convention, typical convention is main is the plan. But not necessary.
So we know that if those are two feasible, then the max if I attend the max value will be less equal to the mean value.
The mean value is greater than equal to the maximum.
Yes. Now we have to show that those are equal. If those are not equal, then we can add. There might be a contradiction might arrive if. Yes. Is there a gap between them?
They are going to go on. So rather don't look at the gap, just try to say that the other direction inequality is not true. That's what essentially it means. One direction we have big duality. For strong duality to not hold, the other direction will not hold. So suppose that doesn't hold. So because there is this language of Farkas lemma, if one doesn't hold, something else holds. That's why I have been looking at the gap, because the fact that inequality is there. How is that inequality which will not hold when there is strong duality? Once you write it down, the proof is immediate. You have big duality. The reverse inequality doesn't hold is what it means by strong duality does not hold. And if you write it in terms of the language of Farkas, you immediately see what it is. So big duality is medium here. What do I know? Can you tell me what do I know from big duality? Implies something. And let's take X to be feasible here, Y to be feasible here. Can you tell me the relationship between
Value of triangle is value of triangle is greater than equal to. Oh, sorry, less.
switch the orders. Always remember the min problem is lower bounded by the max problem. So y would be that's one x of the y. It is a pair. Now the strong one is strong duality is not hold. What will be the condition to not hold? And let's take gamma to be the value of the dual option. Okay, so let gamma equal to b of y star. We revise our property. B of that is the values. With the optimal value of the dual.
Lemma is strictly greater than C transpose U.
Lemma is strictly greater than
C transpose X. C transpose X.
okay. So. Which. Use the language of the creator. There is not duality. What can you say? Which condition doesn't hold so that I can apply for other dilemmas? So there is no found duality. What can you say in terms of the matrix A, vector B, and C? Say something. You can only half the page. See, this is not achievable by the triangle. What does it mean? That it exists no X. Then that X less than B and C transpose X is equal to or more than or less than more than. So unless you use that language, you'll not be able to apply that. So some pushing you to do. Given the fact strong duality doesn't hold, what does it mean for that problem?
There doesn't definitely need to if such that AX less equals to B and C transpose X is
Greater than or equal to log. Now we are good to go. Now which lemma should have? Write everything down. So one prime doesn't hold. So what hold? Two. And that's all we do. So the point is that the proof is not very difficult. You just get used to the language. If there is no strong duality, something happens for these three things. There is no X such that X is greater than B and C transpose X is greater than B. Well, let B of the star optimally. Yeah. There is no big duality. Strong duality. It implies that there exists no X. This I didn't make it. X. B. So far, I don't know nothing, but I can let go. So this implies by lemma prime. One prime does not. Now what do I do? The two prime. Two prime, one is what? Now, first thing to get rid of it, can random in zero. So again, we have possibility be divided. So is it possible that lambda can be zero? So suppose lambda is zero, what will go? Let's try it out. Let's look at this. If lambda is zero, what does it tell you? A transpose y is equal to. And
That is why
nothing more.
the
What does it tell you?
the transpose y is
The transpose. And y is
b is negative. B is equal to 0.
so this will imply again using Farkas lemma. It exists no x such that Ax. So this is a contradiction to our starting that there exists no physical point. So both prime and negative. Now leave this question mark. Which lemma to apply? Prime or non-prime? Or level impacts. So
There's a prime.
whichever one. That's the way to go home. Check for yourself. Which one of primes. So lambda equal to 0 is eliminated. Now let's look at these equations. All we have to do is to come with the contradiction. Right? That's what we're after. And contradiction will give you the fact that gamma is the optimal value. You should be able to create a new vector whose valuation is lower than gamma. Because here, already prime, we have both prime dual physical solution. We have weak duality. We claim there is no strong duality. That means exactly this. Now we claim that this cannot happen. All I will do is to produce an X. Right, to produce a physical solution in the dual physical solution for which the dual optimum is actually even smaller than gamma. And that will make sure that this doesn't. So how do I create a dual physical solution for which my valuation is lower than gamma? And lambda we have shown to be 1 0. So that's a good thing. Yeah. Really greater than 0. So it's really okay. This there. So all you have to do is just carefully look at what I can take as a physical solution. The valuation is smaller than. Yeah. What is this equation telling you? When lambda is greater than 0, it is equal to y. C lambda is equal to 0. So, y lambda, how that can be right? Correct. So if y is feasible, is y by lambda also feasible?
by transpose.
That's the order. I mean, I was not sure. I think I will do that. Because here is the. If you want, you can. The question really is if y is feasible, is y by lambda also feasible? What is feasibility? That's why I asked. If y is feasible, is y by lambda feasible? Why is it? greater than 0, so is y by lambda. What about this condition? It is shown that y by lambda times a is also equal to c. So, given y is given, we have constructed. We also need. Now what is the relation?
See if you know.
That we can't. Because for particular problem, which means you get into a problem with this group. I want to prove this for any values.
Yeah, but if this is y is equal to c and y by lambda is also equal to c.
Or the fish is going on.
Yeah.
Like you're saying that you are taking that all the quantity like 1 by n, and a is getting out because you're in like yeah, that's how we are having the calculating.
And what is this condition telling you?
The transpose y tilde less than minus 1.
Right.
Y tilde y that.
Yours.
This is minus 1.
1 minus 3. What is the moment? Let's see this is
The transpose y
applying methods, which will come minus here. And say this. So this condition. If we transpose y minus lambda mean lambda gamma is less than 0. What do I get? Y by lambda times b that will be less than mu. Y by lambda I have proven to be feasible. But I know that gamma is my optimal value. So I cannot have a feasible point. So the valuation is lower than that. So it better be at a stronger value. There is a noise down. This one. That's not correct. Let's take.
By the time it's the same we both equations.
Then it should be. There's no ground. That might be it. Yeah, it doesn't affect the line.
But lambda is equal to
Yeah. That could be it. So what have we done? We have actually chosen. It's not done. So that's what my 5 minutes. I will tell you something even more interesting property. Okay. Any questions? I will post these notes so that I not proven the one prime to 2 prime and one proven to right plus. But proof is very easy. But my effort of the ones for Okay. component of y zero be greater than zero implies that the ith constraint is met. You also see a counterpart of this particular message. For the moment, it is. Any idea what is going on? So taking 2 points, x0 is primal feasible, y0 is dual feasible. The valuations are identical. That means that is true provided the following condition that the dual variable corresponding to the ith constraint y0 y, if it is greater than 0, then at the solution you have created for yourself x0, the ith constraint is set. And the reverse that if this is true for all i's, then the 2 points are actually out. They can do it. Proof is not difficult. So, has anybody noticed that the equality itself is somewhat special? That C transpose x0 is equal to y transpose B. I have not said anything about the optimality. Are x0s and y0s optimal? Everybody coming? That if C if there exists an x0 and y0, so that C transpose x is equal to y transpose B. Are x0s and y0s the respective optimal answers? I'll leave that for your exercise. Not guilty of doing a homework, right? So you go back home today, just try to do it. Right? If x0 and y0 satisfy the relationship, then C transpose x0 is equal to y transpose B, then x0 and y0s are in fact the respective optimal answers.
If the ith component of y0 is 0, then whatever the b is, we don't care. But if it is non-zero, then the C transpose x naught is basically from the dual problem. No, from the primal problem is basically we are getting that not dual problem. C transpose x naught is exactly A. Right.
So, which direction you want to go?
So the if that holds, then
Okay.
so whenever ith component is non-zero, that equation holds. Basically, I have to prove that Ax equals to B holds.
AIX
Yeah.
equal to BI whenever YI is greater than 0.
Yes. No. We have to prove.
You go in that direction. Right?
Yes. Yes. So right now we have given the condition that if the ith component is positive, then that holds. Then I have to prove that C transpose x naught equals to y not transpose B. So for the particular choice of y naught, we are having that whenever the ith component is non-negative, non-zero, we have the equality. And from the primal problem.
So yeah, the right side is basically consumption over all items.
All right. Yeah. Okay, let's go to this direction. So what is vector transpose B? The long model. We will change and B they will come. Do that. We're gonna write this in terms of A's using this property. I want to write it there. Summation. See, what matters? The one which are non-zero. And whenever it's non-zero, what is it? Bj equal to
AI.
right. So I think with J, Aj, X. Now exists. You just keep shifting them around and you get the right answer. So all there is to it is already happening. All the division is already there. Let's call this because J. All there is pure algebra. Let's rewriting for that. The conditions work out. I'm going to switch order. Also now, see transport is not the power. And I will get one by first to zero out. Coming on the inside. This patient. What is this quantity? Transport y is equal to what direction is? All these things are actually somebody prove it as now not difficult to prove. How to exercise it, that's the initial problem. When you encounter your problem, how will actually link it? How will you do that? This is the one thing I want to show other things. Let's start with Excel. The long term, zero iron. To follow any particular step, stop me. I'm just rewriting until I come to the counter point, I'll keep it. So far, I just done. I'll do. What can I do here? I want to claim that if this is true, then this also is. That's what I want to show. So far, I have not used the fact that these two quantities are equal. What is it that are equal to? And then use the fact. What is that's the equal to. But what are the terms that equation? That is equal to is an equality. So what does that mean? If any y is 0 j, which is non-zero, it better be that this is equal. Otherwise, this equality will never, this inequality will never be.
Eternal.
That's all the complement is. So, I don't know, I'm going to be in words there for. Let me see. Or. Which is given. That's. Okay, so you've done very good, maybe. But what exercise I'm doing for you is to show that if such a condition is true for x0 or y0, there is back optimizers. The rest will be, anyway, you can watch the video. I will also post the notes so that you can see them. One remaining.
This it is already done, right?
Sorry,
Like that one.
we haven't done that.
Like arriving the maximum from below and minimum from above.
That's all you have to do.